Hello, testing. Think we should be live. I'm gonna give it a minute here. Make sure that we are streaming in the right places. And as always, if somebody in the chat wants to say hello and verify that you can hear me, that would be great. And maybe let me know how you are doing. And let me just, make sure that everything is sent out. How's everyone doing today? I see some people here already. No one talked in the chat yet. Right. Looks like we're live on YouTube and live on LinkedIn. And cool. I'm going to give it a minute for people to join in. And let me just make sure that Eventbrite sent out. It was being a little slow this morning, so I just want to make sure that the emails to everyone sent out. Oh, and I have a fun question. So, well, one, you can always put in the chat, say hello, and maybe where you're watching from. I think that's always really fun to hear. But also, if you have a AI or machine learning book recommendation, put it in the chat as well. Whether that's just a book you enjoyed reading when you're getting started with machine learning, or maybe it's something you're reading now that you're really enjoying and it's going deeper on an advanced topic. Let me know in the chat what you're reading. I've been doing a book club where we've been picking a new book a month right now, and that's been really fun. We're currently reading Natural Language Processing with Transformers, and it's a really good book and really good introduction to Transformers and the whole like Hugging Face ecosystem. So I definitely recommend it so far. I'm about a little over halfway through it. And again, I'm just making sure we're live everywhere and that the Eventbrite sent out the right link. It looks like people are joining. Awesome. I'm just going to give people a couple minutes to join in. So again, if you want to say hello in the chat, maybe where you're watching from. I see more people joining in, so I'm going to repeat. If you have a AI book or a machine learning book recommendation, throw it in the chat as well. I'm always looking for the next one to read, and we'll probably do that through a book club as well. And while people are still joining in, I will share some links to get started here. We're going to go through some slides first, and then a lot of this will be hands-on, us running code, but there's going to be some slides kind of introducing the topics. And I'm just going to share some setup links while people are still joining in here. So one, probably the only account that you'll have to create that you probably don't already have is going to be a ylabs account. If you want to follow along with the hands-on portion where we use it, you can create that there at this ylabs.ai/free. And I'm going to copy these over in the YouTube chat, and then I'll put them in the LinkedIn chat as well. And just noting, if you're watching on YouTube, all the links that we point to are also in the description. So you can come back or click on them down there. Or if you're coming back and watching the recording, you should be able to find everything in the description below. And then we're going to be running code out of this Google Colab notebook, which again, I'll talk more about this when we get to that hands-on portion. And then we're going to be using an open source library that we maintain at ylabs called ylogs. And I'm going to share the GitHub to that. And as always, we appreciate a GitHub star on our open source work. So if you want to check out that GitHub, give us a star, always appreciated. And then we also have a Slack channel. So I won't be looking at the Slack channel during the workshop, but it's going to be a good place for you to send questions to later. So if you like what you see here and you want to set it up in your own projects and you have some questions about it, ask them in the Slack channel. I'll share that. And then I'll just quickly mention too, so we're not going to be using this today, but we have a workshop, actually 2 workshops next week using it. Our other open source library called LangKit, which is a about extracting metrics for large language models. So if you're interested in learning about how to monitor LLMs, come back to one of the workshops next week, which you can also find at ylabs.ai/events. Share that. And again, I just saw, more people join in. All the links that I did share are in the description below on YouTube, and I'm just going to share them real quick on LinkedIn for anyone who wants to follow along there, and then we'll go ahead, start going through the slides, and then again, like I'd mentioned, most of this is going to be a hands-on code, and hopefully you'll want to follow along. And if you're just joining in, say hello in the chat, maybe where you're watching from, what you're building with machine learning, and maybe why you might be interested in ML monitoring specifically. It'd be great to hear. And yeah, let me just copy these over real quick, and then we'll get rolling. But it's always fun to hear a little bit about the audience. So again, if you want to share, at least maybe where you're watching from, that'd be great. All right. All right, I'm gonna get going through the slides, and feel free to ask questions as we go. I will be monitoring the chat, and if I don't get to it, feel free to ask it again or wait to the end, and I'll try to get to there. Sometimes, if the chat is too noisy, I might not see it, or if it just doesn't fit the section, and I want to keep moving on. But I'll try to get to everything that I can. Someone said they're watching from Atlanta, Georgia. Awesome. I haven't been to Atlanta, but I used to go up to Savannah, Georgia quite a bit, which is really cool. All right, so we're going to get going. This is Intro to ML Monitoring. We're going to talk about how to get started with ML monitoring and AI observability, as well as look at some things like data quality, explainability, and measuring some bias in models in production. So again, what this workshop is, it's a hopefully very friendly introduction to ML monitoring. It's kind of designed with no previous experience expected, but definitely knowing some Python and machine learning concepts will be helpful, but you'll still be able to run all the code, and I'll be talking about everything. So, no matter what your experience level is, hopefully you'll be able to learn from this. We're going to cover some high level concepts and then implement those concepts with around ML monitoring. And just keep in mind, you can't learn everything about a whole field in 1+ hours, 2 hours, however long this workshop's going to be. Probably in total, if you stay for the whole thing, like an hour and a half or so. But most of it's going to be covered in the first hour. So if you and then there'll be more advanced concepts a little bit after that. So again, depending on your experience, it could feel fast-paced or challenging, and that's okay. Just keep learning and asking questions. So just a little bit about the agenda. We're doing the quick intro right now. We're going to go through a little bit of slides. Again, it won't be too much. And then we're going to go in and actually run code, set up a system where we can monitor data drift, look at our model outputs and performance in production. And then we're going to go on to kind of a second section where we'll do bias tracing and explainability. So we're going to look at like bias in models in production, see how we can use some common explainability metrics to help us. And then we're going to dive a little bit deeper into just the open source library and see how we can implement ML monitoring and data quality checks with ylogs in our Python environment. So most of this whole first chunk will probably be in the first hour or so. And then if you want to stay longer for the more advanced concepts, you can. And then also this is going to be recorded. So the same link that you're watching at, whether that's on YouTube or LinkedIn, you can come back to it. And again, the links to follow along are in the description below as well. Quick introduction about myself. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at ylabs. At ylabs, we build tools around enabling AI observability, ML monitoring, data monitoring, various ways to look at your data or models in production, or evaluate it before you put in production, and basically make it more robust and responsible is kind of the words we like to use around it. And for over a decade, I've worked in software or hardware, mostly with startups and small companies, some agencies as well, around Seattle and Central Florida. And in general, I love making things with technology. So if you ever want to talk about anything, feel free to ping me on LinkedIn or wherever you can find me in the Slack channel, and let me know what you're working on. It's always fun to hear what other people are building and potentially how we can collaborate on stuff. All right, so about you. So again, I saw more people join in. If you want to throw in the chat, where are you watching from? Why are you interested in ML monitoring? And then if you want to stay connected, again, there's an introduction channel in that Slack channel. And feel free to introduce yourself there. Again, I won't see what you post there right now. That's a good channel to come back and talk in later. Ask questions to me later as well. It's going to be a good spot for it. So again, if anyone wants to say hello in the chat, and I already saw some people say they're watching from San Francisco. Someone said they're watching from Brazil. Awesome. So I love doing virtual events too. I mean, I love doing in person as well, but virtual events are always really cool because you can, reach different people all over the world and learn from them, which is awesome. Quick slide on setup again. So again, the only thing you'll probably have to do is create a ylabs account. Everything else is going to be used or run in Google Colab. So I'm assuming most people here have a Google account. That's what we're going to run our code with today, something called Colab, which is Google's way of hosting a Jupyter notebook. And then we'll be using scikit-learn to train a model. We're going to be using our open source library called ylogs to create profiles of the data going in and out of the model. And then we'll use ylabs to kind of monitor that data over time and see how we can set a monitor to trigger a workflow or an alert to us. And then we'll briefly look at something called SHAP, which will give us some explainability metrics around our model. So what is ML monitoring? So at a high level architecture, it might look, or graph, it might look something like this. So you have your data and infrastructure pipeline where you're doing your training, your deployment, your inference, and then you're going to have some sort of tool collecting some sort of AI telemetry. And we'll talk more about what that telemetry might be if you're just getting started. And then you're going to use that telemetry to, forecast or detect or set up monitors or kind of query and look at your model in production or your data pipeline and see like what's going on there. And with that, you're going to generate, reports and dashboards, alerts and notifications, or trigger workflows. So if you have a really well-built MLOps pipeline or data pipeline, if data drift occurs or something goes kind of weird with your data, you might be able to build a workflow that can trigger based on what's happening and then, either automatically fix it or annotate some data and then train a new model with that new data, deploy it back in production, and see if it's performing better. So we're going to be using ylogs today to collect the AI telemetry, the open source library that I talked about. And then we're going to store those profiles that we generate on our own environment into ylabs, which is the platform where we can aggregate all those statistics and then set up things like the reports and alerts and notifications. So why do we need ML monitoring? Has anyone put a model in production before? Chances are you've experienced one of these things. If you put a model in production with like actual production users, even if you just put it in yourself and you're building a toy model and you were detecting birds or something with computer vision, you put it outside and then over time, weather changes, you've probably experienced one of these things. And we'll go deeper into some of these, but just want to mention, you have a lot of things that can happen to your model inputs, such as data drift, data quality problems, schema changes. Again, we'll dive a little bit deeper into this. I see someone already said yes, which I assume is saying that you had one of these happen. And if you don't mind sharing, you don't have to go into too much details, but if you want to share even just what type you've experienced, was it a data drift? Was it a data quality issue? And if you want to share a little bit more about it, you're more than welcome to. And then with model outputs, you have things like, concept drift, performance over time, bias and fairness in production, and we can use explainability to kind of understand why our model's making some of these decisions. So again, we'll dive deeper into these, but we have a saying that bad data happens to good models. So no matter how much evaluation you do and training data you have, potentially, or very likely when you put a model in production, it's going to encounter some stuff it's never seen before, or there's going to be some sort of data quality issue, even if you have a really controlled environment. And I talked a lot about how stuff can go wrong, but you can also use a lot of these metrics basically to make your model better. So even if it's not necessarily something going wrong with your model, but you can see that there's room for improvement, you can take that new production data, usually annotate it, retrain a model with it, and make it even more robust. So a couple data quality examples. And again, if you want to share which one you experienced, that'd be great. So you have external changes like an input sensor is damaged or causing bad data. Data was manually entered incorrectly. This is pretty common. So if people are manually entering data in an Excel sheet and they accidentally put an extra 0 or a decimal point in the wrong place, that can really, change the way the data looks. A camera, if you're doing some sort of computer vision work, is pointing in the wrong direction. Or I've had it where people have turned off lights in a factory or something, and then your camera just sees really dark images. Another common one that people often say they've experienced during these workshops and when I talk to people is a schema changes somewhere down the line in one of their libraries. They update it. They didn't, notice what change was occurring, and some sort of schema change. So the output from a library no longer quite matches what they were expecting, and that can really throw off everything down in your pipeline. So you can set up monitoring on this, and we'll see a couple ways to do this today. One, just kind of overall on our observability platform, but also writing essentially little unit tests to do data quality validation with ylogs. Some data drift examples. So this is where I quickly mentioned, the input data is coming into your model, and a common thing or a common way to think of this is the input data going into your model no really longer maybe quite matches the distribution of your training data. So a good kind of visual example that I like to use is if you had a computer vision model, and again, it doesn't need to be computer vision though, this can happen for tabular or language, etc. But if you had a computer vision model and you were looking at some sort of animal outside, and all the images you trained your model on were taken during the summer, so it's all very bright, let's say it's very sunny, there's always green grass in the background, and then you want to use that same model in the winter, and maybe there's snow in the background, so instead of being green, it's white, maybe it's much darker. Chances are that if your model is trained just on one variation of that group of images, like summer data, it may not be performing as well in this new kind of seasonal drift that happened. But another common use case is like a new group of users, like maybe you had an online store and it was really popular with I don't know, people in their 60s or something, and then you have like younger people using it and they want to shop differently, and now the shopping behaviors changed. Or just consumer preferences have changed, which is very common, right? Like people really were buying fidget spinners however many years ago, and now that's, not something you see too much of probably. And again, if you want to throw an example that you've seen in the chat, definitely feel free to. And an example of concept drift. This is not the input data changing like data drift, but the output of the model no longer really maps to the real world data or predictions that you want. So a good example of this that I like to use is the housing market. So let's say you had a model predicting the price of a house, and for just our sake of an explanation right now, let's say it's a very simple model and it's just taking in rooms, number of rooms in the house, and square footage. Well, that input isn't changing, but if you trained your model 10 years ago, the prices are going to be incredibly different than they are today. So you're going to want to keep up in a case like that where the predictions are changing a lot. Your model really no longer maps to the correct prediction, and you would in this case want to retrain your model with the updated prices. And again, if you want to throw examples that you've seen, definitely do so. Somebody said they experience external changes, so schema changes and input data drift. Yeah, I told you schema change is one that I feel like comes up all the time and kind of hard to prevent unless you have some sort of, data quality check in there. And the data drift is also something, if you have it deployed anywhere, from what I've seen, almost always you're going to experience some sort of data drift at some point, just from, any various things of seasonal changes or users changing. Even if it's in a controlled environment, like I mentioned, people might be changing out colors of mats in the background if you're doing like a QA on a production environment or something, and that can throw off your model. Detecting bias in production. So you might have remembered several years ago, there was, I think, a big tech company with a credit card, and they found out, I forget how much later it was, but basically there was something of like men had a very high approval rate and women did not. And it was a whole big issue. And that's something you can kind of monitor in production if you have like these classes or ways you want to group your data. So in this case, if we were just looking at like approval rate and denial rate for credit cards and we wanted to group it by gender, you could do that. In this case, this is showing, it's kind of hard to see. It's okay. Just this is showing like shopping trends for different categories of food. But we'll see how to use this today, where you can kind of use this to group your data in production and see kind of all the predictions happening for those specific groups. And it doesn't have to be a group that's in your data set. For example, I don't think that the credit card prediction, had gender, I really hope not, in their data set like that, but I was able to pick up on something. And then you could add a group to your data, segment it by that group, and then kind of see how it's performing on each segment in production. And that's a good way of seeing or detecting bias early on, and then retraining your model or putting things in to mitigate it very quickly. And then model explainability, and then we're almost done with our slides, and we'll get to the hands-on part, which I think is really fun. So model explainability. So explainability or explainable AI is a field that kind of uses other algorithms or ways to try to explain how a model makes predictions. So not just what came out of it, but like what features were most important to the model, and kind of gives you a little bit of insight to understand the model behavior. So for example, this is like a computer vision example using, I think this is called AutoGrad or AutoCam. CamGrad, I think. I'm mixing up the words a little bit here. But in this way, it's just highlighting the pixels that it thinks are the most important thing for classifying this as an elephant in this case. So it looks like, maybe this tusk here and head, that's kind of the most important thing, that why it made the prediction of an elephant. And then here is a SHAP library, which we're going to use today. And this just gives us kind of some weights to the features that were the most important for a model. In this case, this was for a housing data set, I believe here. And I think this is like a tax bracket or something like that. And that was one of the most important things for making the prediction of a housing price. And then you can see rooms was next. And then I forget what this is, like distance to maybe schools or something like that, age, etc. So it gives you a really good insight of like when you're developing these models of what is the most important thing to that model. And if that feature changes a lot in production, then chances are that that's going to really disrupt the model potentially. Maybe if the feature changed for something that wasn't as important, then it wouldn't matter as much. And so you might want to set like a monitor or a unit test on this more kind of valuable piece of data to the model. And then just to hammer home, setting up a ML monitoring for the first time. And then we actually will go do this. So we know that we want to set up monitoring or analyze change in a ML application. So you kind of probably already know what your pipeline looks like. Maybe it's just you messing around with a model in a notebook right now, but maybe you actually have a pipeline built, and you want to establish where a change can occur. So again, this could be anywhere in your pipeline where schema can change, etc. When you're just getting started though, and maybe you're not sure where to put this, I always recommend start by monitoring the direct input into the model. Because if any changes did occur before that, chances are the input to the model is going to look a little bit different. And then monitor the output from the model. Just starting with those two things can catch probably a lot of the major issues. But if you want to add more into your pipeline, you certainly can. And then at some point, you might want to get some ground truth when you can, actually like annotate some samples and then get performance metrics. But just looking at the direct input, direct output, we'll see again this in action in a little bit here, can give you a lot of insight to how your model's performing. And then, so you want to analyze change. So what type of change are you looking for? Often, if you're just getting started, again, it depends on your application, type of data. And today we're going to be using a tabular data set. And so I recommend comparing any new data coming into your model to a training data set. And so we can then compare that new data to what the model was trained on. And if it changed by a certain amount, then we might want to trigger some sort of alert or workflow. But you could also use something like called a moving window, where maybe you don't want to compare the training data set to the new data, but you want to look at just like a week's worth of data or 90 days worth of data, et cetera. And if something drastically changed in that time frame, then trigger a workflow or an event. And then we know we're analyzing that change, so we want to pick how to analyze it. Is that you setting up some sort of metric for data drift, like distribution distance? Are we looking for missing values, data cardinality, overall performance degradation? Like, is your accuracy going down? These are all different things that you can kind of pick. And we'll go through some of them today and how I'd recommend, again, just getting started if you're not exactly sure what you want. And then you can always add more later to your pipeline. All right, so enough slides. Let's go ahead and implement some ML monitoring and run some code. Hopefully people are excited for that. So I shared this earlier, and if you're watching on YouTube, the links are in the description as well. But I'm going to share a link to a Google Colab notebook. This is where we're going to run all of our code today. So hopefully some of you will want to follow along. And then also I'll share the sign up link again for ylabs. We're going to use this in a little bit after we run some code to send data to it so we can easily set up monitoring. And then I'll quickly mention as well, this is optional. You don't need this for the workshop here. But if you do like what you see and you want to get more features, I would suggest filling out this form. You can get a coupon code for a free trial of the Enterprise Edition. Again, when you sign up right now, if you just follow that sign up link, there's no card or anything required. It should just take a minute to sign up. I think you just verify your email. But if you want to try the more advanced version of this, like if you like what you see today and you want to bring this into a company project or something, I recommend filling out the form and getting the promo code for 30 days free. You'll get some extra features. But again, maybe you just want to save that. You don't need that right now for this workshop. Once you open up the Colab notebook, you're going to want to go to File and save a copy in Drive. I'm going to do this right now, but I'll pause here for a minute for people to follow along. And if at least just one person in the chat wants to let me know that they were able to make a copy, that'd be great, and that you could open this up. Should be good, but occasionally, I don't know, sharing permissions gets reverted or something. So just want to make sure that anyone following along was able to go to this Colab notebook and then hit save a copy in Drive, and it worked for you. No one said it didn't work. Did it not work for you? Sometimes rephrasing the question helps too. All right, so I have my copy. And again, link to the account if you haven't done that already. Someone said done, so it worked. Awesome. Thank you for the feedback. Other useful links, again, just GitHub if you want to check out more about ylogs, and Slack channel if you want to ask questions after the workshop here. All right, so quick note on, awesome. I see a lot of people saying yes. Oh, and real quick, I'll share it one more time over on the LinkedIn stream as well. Thank you, everyone, for saying yes, it worked. Gotta reload. All right. Quick note on Google Colab. So Google Colab's essentially Google's way of hosting a Jupyter Notebook. If you haven't used a Jupyter Notebook before, it's a really popular tool to use as a data scientist or an ML engineer. It allows you to write code, documentation, kind of like what you're seeing, and output visuals all in one place. And I just saw a clump of people join. So if you're joining, we're just getting started to the code part. And if you want to follow along, all the links are in the description below. You'll just want to open up the Google Colab and save a copy in Drive. All right, so let's run this code cell. To run a code cell, you can hit this play button, or when it's highlighted, you can hit Shift Enter, and it'll run the code cell and then kind of move us down one. So often I hit Shift Enter, so you probably won't see me hitting the play button too often. And you'll see it's kind of initializing right now. It's actually connecting to a whole little Ubuntu instance for us here. So you can actually run terminal commands. It's not just code that's nowhere. You actually get access to this little instance. We can see there's a folder called sample data when we kind of listed everything in our directory. We just have to install one library as well, because Google Colab comes pre-installed with a lot of the common ML libraries like scikit-learn, TensorFlow, PyTorch, a whole bunch of other ones that you might commonly use. But if it's not in there, you can run a terminal command with this little exclamation mark at the beginning. So here we're going to pip install ylogs with the visualization. And cool, that already installed. That went really fast today. And all right, so let's go ahead and, oh, if you come back on the recording, and this is looks a little bit different. There's 3 sections here. So this first section, we're going to cover data drift, model drift, and performance. And then the second one, we're going to talk about the bias and fairness in production, and then a little bit deeper into the open source. So if you come back to this and one of this is collapsed or uncollapsed, you can just always hit this little arrow and bring it back out. So we're going to go through this first section here. We're going to import the libraries we're going to use, ylogs, NumPy, Pandas, DateTime, OS, etc. Then we're going to import some stuff from scikit-learn and the Iris dataset. Now, I always just like to note, if you've ever done ML before, you've probably seen the Iris dataset. I promise this is going to get a little bit more interesting than just looking at the regular Iris dataset. But we're going to use it as a baseline to train our model, and then we're going to look at some data. And spoiler alert, that data is going to look a little weird in some places, and we're going to figure out how we can detect that. So let's go ahead and train a model very quickly. Again, we're not going to go too deep into the ML part here. We're going to be training just a quick model, so then we can kind of look at it in production. So here we have our Iris dataset. We have 3 classes and 4 features. So these 4 features are what we're going to use to predict what class this flower belongs to. So the Iris dataset is a dataset of flowers. We have measurements for sepal and petal length and width, and then 3 classes of flowers. And based on the length and width of those petals, we can predict what flower belongs to what class. So here, let's train a baseline model. We're going to use something called k-nearest neighbors. We'll talk about the intuition of that in a second here. But here, we're just importing it from scikit-learn. We're initializing our KNN. We're setting the neighbors to 5. We'll see what that metric actually does here in a second. And then we're going to create our test and training data sets. So we're using train test split, passing in X, which is all those features we talked about, Y, which is the classes. And then we're using 30% of our data to test here. And random state is 42. And then stratify, if you haven't seen that before, it just means we're going to try to put as many of the same classes in our training. So hopefully it's learned across all those different classes. And then here we're going to train the model. And then here we're going to make our little score. And we can see just based on that 30% of the training data or test data that our model's 97% accurate here. And just to recap the intuition of how KNN works, and this is helpful for troubleshooting your model. So even if you don't know all the math behind your ML models, it's really useful to know the intuition of why a model kind of works or behaves the way that it does. So here we have this new piece of data, which is this really dark dot here. And then K in this case is equal to 4. We set ours to 5. And it's looking at the 4 closest classes to it where it ended up. So here we can see it's plotted by sepal length and petal width. And so if this new dot came in, and the 3 closest ones here are versicolor, and then there's 1 virginica, what class would it make a prediction on? Or what class would it predict that this new piece of data belongs to? Versicolor, right? Because the majority of them belongs to that class. There's 1 here, so it might have some sort of probability score saying like, well, I'm pretty confident it's versicolor, but I did see 1 virginica near me, so I could be potentially that as well. So this is going to be important later to kind of troubleshoot our model in production. All right, so let's go ahead and import some batches of data. Don't worry too much about what's happening here. We're just importing some CSVs, and then we're just extracting just the feature names from them. And the important thing to know is we just have 2 data frames now. One contains all the batches of the feature data, and then the others contain the classes. So now we can look at one and see it looks like this. So we have that sepal length and petal length and width, and numbers for each one. And there's 150 rows for each of these, I believe. So we can look at, we just looked at it. I think I don't need that code cell again. All right, so let's go ahead and look at creating a log of these data sets with ylogs. And this is how we're going to essentially monitor our data over time. So ylogs is an open source tool for logging data of any kind. Today we're using tabular data, but you can log metrics around images. We even have another library called LangKit built on top of ylogs, where you can log metrics around large language models or any language model, which is really useful. And how it works is basically we'll see this, I guess, right down below, but they just generate summary statistics of the data sets passed in. So we call these ylogs profiles. And then just for those summary statistics, you can use them to track changes in your data set, create constraints or data validation, and extract key metrics for things like data drift. And it's easy to integrate into almost any Python application. So we have a lot of integrations, but also if you can just get the data in a format like a dictionary or a data frame, you can log it basically from any library. So let's go ahead and see what this looks like. And you'll see what I mean by how it just contains summary statistics. So we're creating a profile called just profile 1 here. We're passing in that data frame, which contained all the metric or contained the sepal and pedal measurements from our data that we imported. And then we're just going to create a view and look at it in pandas. And we can see now that the cardinality is 42. So there's around 42 unique values out of 150 rows here. And if we keep scrolling over, we see we just have other metrics like the max, the mean, the median, the min, and then some other distribution quantile metrics. But this is all that's really in here, besides some other stuff of like, is it a string or not? Sometimes some frequent items. So this doesn't contain your raw data anymore. And this is a really useful feature, in particular for a lot of industries, but one, it makes the profiles really efficient, so they're really easy and quick to send anywhere, even if you're on like an edge device or something like that with a not great internet connection. But then if you're in a industry like healthcare or fintech, or I'm sure there's other industries where this is very important, where you can't send raw data out of your on-prem device or your environment. This doesn't really contain your raw data anymore. It's just a summary statistics, kind of like a lightweight fingerprint of your data. So a lot of industries will actually like using something like this, like I mentioned, specifically healthcare and fintech, where now you're just having these little aggregate statistics, kind of a fancy aggregate of your statistics that you can now move around and monitor really easily. And just with these statistics, you can still do everything like detect data drift or data quality issues. And that's what we're going to see down below. But just want to mention that doesn't contain your raw data. They're super efficient. They're also customizable. So we see some metrics in here right now, but you can always add a custom metric in. So if you're doing something on more advanced data or unstructured data, like I'd mentioned, images or large language models, we have features around that. But if you have a custom metric that you need, you can easily write that as well. And you can learn way more about this, again, by checking out GitHub. I'll share the link one more time in chat here. And there's a whole bunch of examples in GitHub and on our blog as well. All right, so we saw that we created a profile here of one of our batches of data, but let's see how we can really use this or make this very useful over time. So now we're going to write profiles to ylabs. So again, if you didn't sign up yet, you can go to that ylabs.ai/free, and you're going to get some data from here, our API key basically, and see how we can write these profiles up and monitor them for data drift and data quality issues. So if you didn't already, I'll grab this link again. Is where you actually need to sign up now if you didn't, to get your API key. Again, it's free. There's no card required. And it should, I think you just have to verify your email, and then you'll be good to go. So I'm going to give everyone a minute to sign up if they hadn't already. And again, if you're coming back and watching this later, links are also in the description. So once you do sign up, you'll have a page like this. And I'll go through this maybe just twice just to make sure everyone who wants to follow along can. Once you're on the homepage like this, you can go to create resource. And then I'm going to go ahead and clean up a couple of my models here. So these models are projects, and I'm going to delete 2 of them. So I am just hitting edit models and data sets. And I think if you just signed up, there's going to be like a couple kind of toy examples in there. So maybe you'll want to delete at least 1, because we're going to use 2 models for this workshop, and you can have 3 here on the free plan. So I'm going to delete this one, and I'll delete this one. And then I'm going to create a new model. So I'm going to give it a name. You should give it some sort of meaningful name for you. I'm going to call this workshop, I guess. And then for resource type, I'm going to select classification model, because that's what we're building today, is a iris classification model. But if you're building something in the future, like a regression model or a large language model, you can select that here. And all this is really going to do right now is just give you some different metrics and interfaces depending on the type of model that you're monitoring. And you can always change this later as well. So I'm going to hit add models or data set. And if I accidentally selected the wrong one, or I forgot about it, I can come back here and change it, and then just hit save. So now I have my model called workshop. I want to copy over this model ID. I'll go back to my notebook. We'll paste it into model ID. Make sure that you actually don't get any spaces or new line characters. It should just be a string that looks like this in there. And then let's go get our API key. So from the same page, I'm going to go to access tokens. I'll create a new token here as well. Again, I'll just call this workshop. Create new token. It's going to show up here in this blue box. I'm going to hit copy and paste it in. And then we want to get the org ID. So it's also on this page, right under that blue box if we created it, or it's always right here as well. So you can copy that into our org ID section here. And again, make sure you don't have any spaces or new line characters, and then we should be good to go. So I'll go ahead and run this, but I'll pause here too if anyone wants me to go over that again very quickly. Actually, I'll just go ahead and show it again. So if you're on a new page like this, you can hit create resource, but you can also always get to that model page by going to settings, opening up this kind of hamburger menu here, go to settings, go to model and dataset management. And then we're back on that same page. So you would type in, create a model, select it as classification type, and then it should show up here. Copy that model ID. We'll need that. And then from the same page, you go to access token, type in a name. You'll get that blue box with the token, hit copy, paste that in, and then get your org ID either from here or it'll show up under that blue box as well. And then you paste that in, and then you should be good to go here. So I'll wait just a few seconds or a minute here while people are doing that, and let me know if you ran into any issues while following along, or if you have any questions so far. All right, so I ran this, and then we're going to initialize the ylabs writer. So I hit Shift Enter, and then first let's just write a single profile up to ylabs, and then it's going to get more exciting. Just below, we're going to write a whole bunch up and kind of see what this data looks like over time. Oh, I should have mentioned. So when we were importing all that data at that beginning with like all the CSVs, we basically had 7 of them. So we can simulate our model being in production for 7 days. So basically we're simulating like a week's worth of data. But first, let's write up just one profile, see what it looks like in the platform. So I'll go back. You can always go to that homepage by clicking this ylabs icon. I'm going to click into my workshop. And the summary tab gets more interesting the more data you add. So we don't really have too much going on in here, but we can see like there's 4 features, etc. What I'm going to do is navigate directly over to this input tab. And then I'm going to click on this first one, pedal length. So we can see our 4 features are in here now. And now this doesn't look super exciting quite yet, but we can see that we have a profile for a single day here. And it gives us those metrics that we saw when we looked at just the ylogs profile. So it had the median, the max, the mean, etc., our upper and lower bounds of our data. And this gives us some good insight of like what was going on that day, or what our data looked like in that day. So let's go back to the notebook. Run this code below. So all we're doing is basically looping through all 7 of those data frames, subtracting a day from each one, and rewriting the date time of our profile to be -1 day for each loop. So by default, when you push something up with just like this ylabs writer and just a couple lines of code, the date time is going to be the date and time when you write it up, but you can overwrite it with setting this date time stamp to date time. So now, if we refresh here, we can see that we have this whole little cool time series view of our data. And if for some reason you don't, because you can mess around with the dates here, this kind of shows everything on those dates, you can always hit this batch profile lineage button, and that'll take you to basically the days that contain data. So we can now start investigating our data just visually. We'll see how to set up a monitor very quickly here. But if I zoom in just so you can see it, if you're following along, it should be easy for you to see. But if we look at this first day, let's just look at like the median, for example. At least for now, we can see the median is 4.2. This is, again, just one feature in our data set, so it's the pedal length. We can see the median is 4.3 here. 4.2 again. So that these are all pretty similar, right? And then this one looks way different. It went all the way up to 9.2. So something's interesting in our data there. It went really high versus like all the other batches of the days. This one looks interesting. It's got some very high thresholds and more lower bound data points, but we can see the median is 5, so it definitely went up, but maybe not quite as much as this other one. This day, everything is 0, which is interesting. The median, the max, the min. So that kind of tells us this data set is just zeros. That's probably an issue. Maybe we should have a rule, and we'll see how to set this up with ylogs later. But maybe you should have some sort of unit test rule of like, a measurement shouldn't be 0. And then we can see this one again is kind of a normal distribution to our other days. So this is great. We can kind of visually look at this and see that, something is probably going on at this day. This day also looks interesting. Like some at least were very high values. Like it says the max was 33. So there was some pedal measurement of 33 centimeters when everything else is like 4 or 6. Again, maybe we should have a rule that's like way out of bounds and probably shouldn't be considered a right value. That's probably a data quality issue there. But we didn't have those rules set up. But now we have monitoring, so we could actually go write those rules now. But let's also look at a way where instead of us like looking at this data every day and seeing if something's going on, let's see how we can set up a monitor to trigger an alert and let us know when something looks off. Or with that alert, again, you could also set up some sort of integration with your data pipeline or MLOps pipeline to do something like retrain a model or annotate some data. So I'm going to hit this setup monitors button. Oh, and actually, before I do this, I think I forgot. So I'm going to go back to my notebook. We want to run this one last code cell under that. This is going to write something called a reference profile. So when I mentioned one way of setting up a monitor would be comparing any new input data to your model to your training data set. That's what we're going to do here. And we're creating something called a reference profile. So we just wrote up a profile kind of like we did before. But we're giving it a name, so it's going to be a static profile, and it's not going to go in our time series here. It's just going to be something that we can compare that time series against now. So what I'm going to do is we have some presets down here that you can enable or configure, but I'm going to go ahead and hit this new custom monitor button. And we have two options. We have a UI builder, which is great, and you could do most of the monitoring here, but we also have a JSON configuration option. So if you want to get really into setting up monitors and complete customization, you can do that in the JSON configuration. But for today, we're going to use the UI builder. So we can click into that. We have some options here. What are we monitoring for? Data drift, data quality, model performance. We're going to keep it selected on drift, and we're going to be looking at the input columns. Next. We're going to go ahead and look at the entire data set, but you can also do specific segments of your data set or specific groups. And we only have one option here because all of our values are non-discrete, so they're pretty continuous number. But if you had discrete values like categories or something, you could also set a data drift on that. And we're going to also select all columns of this type. But again, you could manually select specific columns. So if you have, 100 features or more in your model, you might not want to set a monitor on every single one, or at least how you're tuning this specific monitor. So it's good to select the specific columns that you want it on. And here we'll go ahead and leave this on Hellinger distance, but we have a few other ones in here. This is the algorithm for calculating data drift, and Hellinger distance is a pretty good one. Again, if you don't have a very specific use case or know what these are specifically good at, Hellinger distance is usually pretty good for looking at discrete and non-discrete values. And then this is going to be the distance that it drifts where we're going to trigger an alert. So the higher the number this is, the less sensitive it would be. So if I said, only trigger when the drift is 90%, is going to be a less sensitive monitor, and it's only going to trigger when something really big shifts. Let's go ahead and make ours a little bit more sensitive, though. So I'm going to set it at 0.6. Hit next. And then here, I was talking earlier about comparing the training data set versus a trailing window. We're going to select reference profile here, and then we have our iris training profile here. So what we're going to be looking at is all this new time series input data, compare it against the training data set. And then here, this is just kind of for you. You can set up, the severity alert just kind of tells you if the drift of this monitor happened, is it really low, high priority? And then there's some actions here. By default, it's going to be email, but you can set up things like Slack or PagerDuty integrations to tie back into your workflow very easily just in the settings. So I'm going to go ahead and hit save. And now if I go back to my input tab here, let's click back into that pedal length. We have this little preview option. And by default, the monitor, at least in the free version, is going to run every 24 hours. One thing in the enterprise version is you can set up a monitor hourly as well. So you can see it's going to run in about 6 hours. But let's go ahead and hit preview now. And we'd see that on all 3 of those days that we were kind of investigating here, we now have an alert triggered for each one. And this little purple line shows us the drift distance. So we can see on that day where it went really high, the high number, the drift was really high, over 9. So if we wanted this to be a little less sensitive, like I mentioned, we could just have the drift set at 9 and it would have triggered here. This day is interesting because it's the one where we saw the median didn't change. Most of the data kind of fell in range, but then it did have some really high numbers and low numbers, which is interesting. So when we kind of tuned the monitor to be a little bit more sensitive, it was able to catch that one as well. And then here we can see it also caught this. This is also really high drift because everything was 0 and the other ones were not, or nothing in the training data set was, right? So this is a drift of actually 1. It's like everything is drifted. So it would have caught that with that high 0.9 as well if we left it at that. So now we have this trigger. In this case, it'll email us when it actually runs, but you could also set up Slack or the PagerDuty integration like I mentioned. So what do people think of this? We still have more to go in the notebook, but this is like kind of one of the core things of we are able to get our data going into our model, visualize it over time, set up a monitor on it. So when something does kind of look out of place, it's able to at least trigger an alert so we can go investigate it. Or again, depending on our pipeline, we could build out some more advanced workflows and the trigger could go trigger one of those. Does it seem interesting or useful in projects you've talked about? I know, someone talked about, they shared their story of experiencing a schema change and data drift in production. And I'm not sure how you caught it because often you'll catch it in various ways. Like you might go spot check these things sometimes, or users might bring it up to you that your model's not performing well, like it's making weird recommendations or something like that. And with monitoring like this, one, hopefully it gives you really good insight where you're going to catch it much quicker and be able to mitigate it very quickly. Or it gives you insight of how to maybe write some data quality rules later as well. Yeah, let me know in the chat if you think this is an interesting tool and maybe something you'll want to use in projects later. So I'm going to go back to the notebook and let's look at logging output. So far we just looked at logging the inputs. So I'm going to go ahead and run this. All this is really doing, and I think I kind of wrote some cowboy code for a pandas data frame, but everything's fine. And all it's doing is just appending our probability and class output that the model is predicting to the data frame. So you could do this all at once, by the way, like just get the model prediction and the model input and then write it one time just in that few lines of code. So it looks like a lot more code is happening right now, but really if you're just making a prediction and getting that input, you could do it all at once here and write them up. Makes sense to kind of break it out in the workshop, I think. And then we're going to loop through those 7 days just like we did before with the input. The only difference is we're not writing the whole data set up like we did before. We're specifically saying class output and probability output. And ylabs has a feature where if a column name contains output or outputs, what it does is it puts it over in this outputs tab here. So if I click on this, we see now we have our class output and probability output. And the reason is, like in this case, you could have those in here and you could monitor them here as well. There's some extra features around specifically monitoring and investigating outputs, but also if you have like hundreds of features, it can make sense to kind of look at your outputs and inputs differently. So let's look at our class outputs, which is a category in this case. And we can see those first 3 days, which we saw those distributions look pretty similar. Same with the last day. We can actually see the class distribution for that is also pretty similar. And then this day looks very different. It's almost all Virginica. And then this one is much higher Virginica, still some Setosa, slightly lower. It's like lower in everything, but still higher Virginica. And then this one's interesting. It's all 100% Setosa. And then this is back to kind of a pretty even distribution, around 50 of each, right? So just looking at this output, we could also see maybe something is wrong with our model. So if we had a lot of historic data, we could know that, well, the distribution's usually around 50 of each in this case, and then this day looks off. This one looks a little off. This one looks very off as well. What's going on here? And this is where going back to the intuition of K&N kind of comes handy, right? So we already knew just by looking at our input data that some of the values were really low, like all the way to 0. And if they were all 0, we don't have any data quality tests written, so it's just still going to be looking at the closest 5 neighbors in our case, and all 5 of them would be Setosa. And the ones that were really high, again, we don't have any constraints or data validation happening right now. So even if it's way out of the distribution of all this other data, it's still looking at the closest 5. And because we saw some of those were like number 33 or something like that, like very high, very different numbers. It would still be looking at Virginica as the 5 closest neighbors and making this prediction. So just looking at the input, like we already did, and the output here can give us a lot of insight to our models. And we could set up a monitor, just like we did our inputs, on this output to, look at cardinality or a drift on these categorical data, and that would also trigger an alert. So we'd say, hey, the input changed a lot, and also the model output changed a lot. So without even looking at ground truth so far, we have a really good idea that our model is probably not behaving the way we want it to, and maybe we have a data quality issue. Someone said they like the monitoring of ylabs, and the interface is not 100% intuitive, so would love to have a study and learn it a bit more. Awesome. Yeah, thank you for the feedback. And hopefully going through the workshop will make it a little bit easier for you to understand how to set it up. But totally get it. There's a lot of kind of parts to it. And we're always looking to make it more intuitive. So if you also have any specific feedback that we can incorporate, let us know for sure. Even if it's not right now, you can ping me in a message on LinkedIn or in the Slack channel and let me know anything specifically you think we should change. I would love to hear it. And we could look at our probability output. We can see that this is just like kind of the confidence score like we were talking about. We can see that it kind of changed on all those 3 days as well. So let's go back to the notebook. Again, it's really cool without even ground truth yet. We are able to get a lot of insight about our model from the input and just the output. So the bare minimum of what I would set up for monitoring, like I had mentioned at the beginning. So let's go ahead and look at our data frame again. We're going to add the ground truth to it now. So we already had this because we imported it in, but this would be in real life. Now you're kind of adding, probably like you're going to go and manually annotate this or send this off to some sort of annotation group, and then they'll give you the ground truth. And then we added this to our data frame here. So now we can compare what was the class predicted by our model to what the actual class was and get even more insight of how our data was performing. So then we can calculate things like accuracy, F1 score, etc. And we're going to log it up just like we did before. We're looping through 7 days. And then we're using this log classification metrics. If you're using regression models, you can use log regression metrics. We're going to pass up the ground truth and the class output and compare those in the platform now. So let's go to the performance tab. And we can see, again, on those exact 3 days, it's just funny looking how much big of a dip it is. The performance dropped a lot. So this number here is basically the last batch that was read. So it says 97% accurate. That was for this last day over here. But we can see if we look at a day-by-day basis, the first 3 days that kind of had the normal distribution, they look fine. Depending on what you're trying to do, but over 90% accurate for all of them. That day where everything was really high, it's only 30%. And then when it's all, this is the one that actually kind of looked maybe okay, distribution-wise. is, only 46% accurate. So actually it affected it more than I would have thought just by looking at how much the data changed. And then the other one is only 33. There was all zeros because it was still making roughly a third of the data set it was still right on. And then this one is 97. So it went back up on that normal distribution. So this is a good way. Again, you could set up monitors on these as well. So if you're getting ground truth and actually measuring performance here, like accuracy and recall, you could also set up monitoring here. So when accuracy or any of these scores drastically drop, you can trigger an alert as well. And you can compare these. So we'll see this in a little bit. You can compare performance like this with segments or with other models. So you could select another one here. I don't have another classification model, but I could select another model here and then actually look at performance over time overlaid with each other. And that's a really cool feature if you're doing something like shadow deployment of models is something I talk about a lot. So you might take this newly annotated data, retrain a model, put it back out kind of in production, but as a shadow deployment, which means you're getting production data to it. You're seeing how it's performing on that production data, but it's not actually the model that's delivering results to the end user yet. So you can now compare at least two models together, and then maybe over a week's worth of time or something, you're going to say, oh, this model is way better. Let's go ahead and deploy that one into production. All right. So I still see there's quite a few people here. Chat is a little quieter today. So again, let me know if you have any questions so far or seems interesting. I hope people said it seems interesting. They gave some feedback about the interface. That's great. If you have anything like that you want to share here, let me know. Otherwise, we're going to keep going. So this is kind of the last part of that first section where we went through, we saw how to set up monitoring for your inputs and outputs and performance. This next section, we're going to dive into monitoring for bias and fairness, kind of like I talked about, where we can now group our data in production and see how it's performing based on various metrics. And then we'll also look a little bit about explainability and how we might use that to kind of understand how we would set up monitors on our models. Everyone ready for the next part? I'm going to take that as a yes then. All right, so this first part, I'm going to go through very fast because it's almost exactly the same as what we did above. We're just going to train a model exactly like we did before with the Iris dataset. We're going to bring in different data, though, this time. So it's going to be a little bit harder for us to figure out what's going on. And that's where we're going to use some of the features like looking for app bias in production. So again, I'm just going to run through this. We're just training a model exactly like we did before. We're even using a KNN model exactly like we did before. This is slightly different. Again, you don't have to worry about what's different here yet. It's going to leave us with 7 days or 7 batches of data that we're going to use to simulate being in production for a week. And then we have our data frame and our data frame target. So again, this contains all of our features. This contains the ground truth so that we can go look at the ground truth later on this. But this data, as again, spoiler alert, so, something's going to be a little off in this data, but it's going to be different than what we just saw. So we're going to want to use a different feature to kind of look at it. And our data set looks a slightly bit different. So we have our sepal and petal length, just like we did before. But now we also have this separate value called state. And that's going to be something that we have the iris data set, but now we also know where the iris was grown in this case. And it's going to be what we're going to segment our data on so we can kind of drill down into those different segments and see what it looks like for each of them. So again, create a profile with ylogs, just like we did before. Just contains those summary statistics about our data set. So really none of our raw data. And all right, so I'm just going to set up one more model for this workshop. So I'm going to go back to ylabs and go back to my homepage, create a new resource. I'll just call this bias. Again, you can call it whatever you want. Resource type, again, is classification model. Add resource. Copy this over. Again, my number is model 298. If you just made an account, it's going to be a much lower number. So I'll paste this in. And I saw, some numbers of people joining again. Just if you ever join in and you want to kind of pick up some of the code, all the links are in the description below. So if you're either coming in now or you're watching this later as a recording, you can go get the notebook and run everything yourself. All right, so I set my model to 298. I didn't have to set the API key again or org ID because we already did that above. But if you were just running this section and you didn't run the above section, you could uncomment this and then set the API key and org ID. All right. So again, reiterating, writing just a single profile with the regular or current date and time is very simple. It's just a couple lines of code. Ours looks a little more complicated because we're looping through all of that data and making predictions here. So let's go ahead and create a data frame in this case. And all that's doing is looping through like we did before. We're making predictions. We're getting the probability score from the KNN, which is kind of that confidence score almost, or basically saying like how many of the 5 that I looked at belong to a specific class. And then we're just appending these to our data frame. So now we have all the features, the state, which is where the flowers are grown in this case, the output class from our model, and then the probability output again as well. So let's go ahead and write them up to ylabs just like we did before. But one thing is different here is we're importing this segmentation partition. We're importing segment on column. So again, we're telling it to segment on state here. So now we'll have a little bit more granularity that we can drill down in our data and see how it's performing. So again, this could be something like we had mentioned for credit cards or certain financial institutions. You might want to do this on things like gender or any other type of group of data. Like it could be categories for your shopping items or anything like that. And if you just want to see performance on those specific groups of data, you can add it in. And in our case, we didn't train our model on state. This is a separate kind of group that we're adding in here. So it's not a feature that our model's learning from. It's a group that we've added to our data set here, that we have in our data set that we can group it by. And I'm going to go ahead and actually keep running this code, and then let's go back to ylabs platform. So we'll run all the code in this section, or for the bias part anyway, and then we'll come back, or just go back to the ylabs platform. So here I'm also doing a reference profile again, and then we're going to, just like before, we're going to add the classification metrics. So this will go in our performance tab. Again, the only different thing we're doing is running that segment on column. And let's go ahead and let's run this code too, and everything will be in ylabs, and then we'll just go look at it all at once. So we're going to pip install SHAP. Actually, well, we'll pip install that. We'll come back to this for the feature importance. We'll go to ylabs and we'll look at the segmentation piece now. So I'll go to ylabs, go back home. I'm going to click into my bias model that I just set up. Now, if I go to the inputs tab and click on petal length, we have a time series view, kind of like we had before. In this case, if you hover over this and just kind of visually, you can see there isn't a real big change happening. Like we saw before, we could clearly kind of detect that, like these days look off. There's probably clearly drift happening on here. I could set up a monitor on it. If you look at these, they're actually very, very similar. If not exactly. No, they're not exactly, but they're very similar for each of these days. There isn't going to be a clear sign of drift happening here. Now we could also go into segments because we have our 3 segments. So these are they're grown in Florida, Missouri, and Washington for this case. And I can click into a specific one here. I can look at petal length for Florida, and we can manually inspect. Kind of maybe we'll just glance at the median here is like 4 point something on one of them, but it's usually 5 whatever on the other ones. I can now look at Missouri. See, I think it's a little bit lower on these ones. And then I could look at Washington. Also see that just the median's a little bit lower. So maybe in this case, again, we're just manually inspecting right now. There's a better way to kind of visualize this, but just manually looking and eyeballing the median for these 3 kind of classes, we could see that Florida median was higher. So again, if our model doesn't count for that distribution and just one of these segments is higher, but wasn't enough on our complete data set to throw it off, something could be going on here. So what we can do is go to this tracing tab, which is really cool. Yeah, reload that. So if that chart didn't show up there for whatever reason when you first click on it, just hit reload, then hopefully it'll show up like this. So we can go to this tracing tab, and we have a really cool way of visualizing what's going on each of those groups. So again, we only have 3 here, but you could have a lot more than 3. And here we're looking at all profiles in range. We can look at a comparison profile in a second. We're looking at the accuracy of our model in this case, and then secondary metric. Let's actually look at the false positive rate. So we can see this bar here that the accuracy across all of our profiles for Missouri and Washington are well into the 90s, but Florida is down to 80. So our model is definitely not performing as well on this specific segment for some reason. And then when we eyeballed it really quickly, we saw that the median was much higher. And it wasn't like super high, but it was a little bit higher. So probably enough to throw off the predictions just in this specific case. So there's this cool little bar. If you wanted to say, well, at bare minimum, we're expecting, 90% for all of our models. We can visually see that it's working for Washington, Missouri, but not Florida here. And you can see different metrics as your secondary metric here. So we can see false positive rate is also much higher for Florida than it was for all these other states as well. And we can pick specific profiles to compare against. So even on this first one I chose, the prediction rate's even lower for Florida. So maybe specifically on this day, something happened. I could look at a couple other days and actually see that on this day, it's fine. This day, it's better as well. So we could see that some of these days might be off and either the data looks weird. It gives us a really good insight of like something is going on with this segment, and maybe we can drill down even on specific days of why maybe that happened. And another cool thing we can do is go to this performance, because we have our metrics like F1 score, etc. in here. We can also compare the data by overlaying it. So we could look at Florida, for example. Oops, what's going on here? Might have put in a little weird state there. Let me get rid of everything that was after that question mark. And all right. I'm not sure what happened there. Hopefully that didn't happen for you, but if it did, you could just clear everything after the question mark in your URL, and then you should be able to kind of select these different segments here. So I want to compare all of the data versus Florida on every single day. We could see that the accuracy for each of these days compared to accuracy of the overall data. So Florida is definitely lower in this case, way lower on some specific days, maybe not quite as bad on other days. And we could also compare towards another one. So we could look at it compared to Washington, see how it's performing on against that specific segment and this other segment. So using something like this, you could see, any group of data you can think of for your data. What is performance looking like over time? And are there any problems with any specific segments? So somebody said yes in the chat. That might have been me asking a question. I don't remember what it was. Or maybe you thought this was cool and you were saying, yes, it's awesome. Any questions on this? We'll go back to the notebook here in a second, and we'll implement one other feature to go into ylabs. And then we'll also, after that, go look a little bit more at the open source features. I'll go ahead and go back, but feel free to ask questions. So I already ran this pip install SHAP, which is the library we kind of talked about in the slides, where we can extract some feature importance for our model. So I'm going to import SHAP. I'm going to initialize something called explainer. I'm going to pass in our model, and then I'm going to also pass in our training data set. And then I'm going to pass in the test data set, and it's going to do a whole bunch of stuff in the back end there, kind of figuring out what features for our model kind of have the most weight on making the predictions. So it did that, and our model is pretty simple in this case, so it's going pretty quickly. But if you have a much more complex model, it can take several minutes to run. Let's get a little plot here. And so what's happening is saying petal length and petal width are by far the most important features for our model, the KNN model, at least making those decisions. And again, right, it's just looking at the closest values. And we didn't go ahead and do like a whole EDA, exploratory data analysis, on our data set like you actually would if you're building this model for the first time. But if we were to plot all the variations of sepal and petal width and length, we would see that there's a lot of clumps happening, right? Like here we can see Setosa is pretty much down at the bottom. Versicola is looking pretty good here in the middle. Has a little bit overlap with Virginica, but not too much. And that is kind of for petal width. And which one did it say was the most important is petal length. So, but petal width is also pretty important. So if you were to plot this by petal length, you'd see very much more clear clumps, basically, and not as much overlap on other classes. And so that's what's really why, at least for a KNN model, the petal length is the most important feature. Again, if you use a different model, that might not always be the case. And then petal width is the second most. And then really these sepal width and length aren't that important for our model making the decision. So we could actually probably just look at petal length and get a fairly accurate model just from what we're seeing here. And then we could have petal width and would add more into it. And then these ones, they might be adding some value, obviously, but it's not the most important thing for our specific model today of making the prediction. So we can group these together now just into, we're getting the same data, but we're just putting it into a dictionary format. So we can now pass this data up to ylabs, and you can pass any data like this as a dictionary format. So if you're using SHAP or any other explainability algorithm, if you can get it in a dictionary format like this with the feature name and then the value, you can write it up to ylabs. And we'll write it up by using this feature weights writer. Very similar to like we did before, but we're just importing feature weights and then writing that up by calling feature weights.writer. So we go back to our platform in our same model here. You now click on this explainability tab. And we have those same values that we saw in our notebook, but now they're kind of stored here. And this is really useful if you're working, with teams. Not everyone probably saw that in your notebook yet. And you can quickly click into this. So and then explore your petal length. Quickly explore the most important features, which ones might not be as important. And then this is where maybe you'll want to set up different monitoring severity, for example, or different sensitivities for your monitor. So if petal length changed, that might be more important for your model making decision. Maybe you want to make your monitor more sensitive for that specific feature, and maybe you don't care as much for one of these other ones. And again, we have a pretty simple model and data set today with just these 4 features and a KNN model, but you might have way more features than that. And this can be really helpful kind of figuring out how to set up monitors and look at your data in production. Any questions on that? I know we went super fast and very, very kind of crash course into SHAP. There's a lot you can learn about it that we obviously did not go into today. But if not, we'll go ahead and dive more into the open source of data and ML monitoring using ylabs, which is our open source library. I'm going to take a second here and drink some water. And again, I'll wait and see if anyone has any questions as well. All right. Still no questions. I still see there's a fair amount of people here, but you all are a little quieter today, which is fine. But just want to make sure you don't have any questions that I did not get to. All right, I'm going to keep going in the notebook. All right, so let's look at some of the things we kind of talked about, like setting up data constraints, kind of like a quality test for our data, and a little bit about visualizing and looking at data drift, but just in our local environment. And we can use ylabs to do that. So what I'm going to do is go ahead and just create a whole bunch of profiles. We already saw how to create profiles with ylabs. We're just going to go ahead and create like 10 of them here. And as you run through this, I encourage you, if you want to change any of these numbers, like it says profile 1 here and profile 2, change that to any of these numbers, and then you can look at a comparison between different profiles and what I'm going to show. So here, we're going to compare, we're going to import the notebook profile visualizer from ylogs, and then we're going to pass in 2 different profiles. And basically, it's a way for us to visually compare them. So profile 1, profile 2. Let's look at this summary drift report here. We get a little bit of visualization here, kind of gives us some idea about the distribution. And then over here, we have this drift score. If I keep scrolling, it says was data drift detected, and then total counts that was in that profile batch. So here we're going to see the p-value, no evidence of drift, no evidence of drift on any of these. And this one is possible drift. Which one is this? Class output. And then I think it has state in here as well. That's why I was like, what is this other one? All right. So now we can kind of drill down into this and overlay the visuals, which I think is really cool. And this gives you kind of a nice histogram chart of looking at the distribution between those 2 profiles. So we can see that, this is pretty overlapping. The orange and blue are 2 different profiles here. Basically, they fall in the same range. We can see, obviously, they're slightly a little bit different on each axis, but not by too much. They basically look very similar. We can look at this other one. And again, pretty similar, except for this did have way more values here in the middle. So that might be throwing off the drift score a little bit. And if we want to look at the raw numbers, we can do that by calling calculate drift scores and then passing in the numbers just like we did before. But instead of getting the visualization, we actually just get the direct drift values here. And by default, ylogs uses KS test, but you can select from other algorithms as well. Again, if you kind of know which one you want to do to calculate your drift metrics, you can select it here or change it here. There's a link right below this section where it shows how to kind of customize all this. But you get this dictionary back with those drift values and, if no drift is detected, etc. So you can actually do a lot just in your local environment now with these values that you're getting. Let's look at another profile. I think this one might have more drift if I remember correctly. If not, you can always change the profiles that you're comparing. Again, I did 1 and 2 before. Now we're doing 2 and 3, but you could change it to another one and kind of see what numbers you're getting. See, so this one is saying detected drift for sure, and that is on the sepal width. We'll make sure we look at that. And I kind of have to scroll in mine because I'm zoomed in. So if you're running this just at 100%, you should be able to see everything pretty good here. So specifically detected drift on sepal width. And so the lower the number this is, the more chance of drift. So if it's basically almost 1, that's saying that they're very similar together. And if this number is much lower, it's saying they're much more different looking. And again, we're just comparing 2 profiles here. So let's go ahead and let me grab the name. I should have had this name, sepal width. I'm going to copy this instead of looking at the petal width or petal length. Sorry, let me delete those new code cells. Let's paste this in. And now we're going to look at sepal width. Kind of able to drill down. Does the distribution look different? And we can see it looks a little bit different. There's still some overlay here, but we can see that there's a lot more higher values of the reference profile. Also, the reference profile goes further out, both on both sides. So there's definitely distribution difference. So for example, maybe we had this blue target profile was our training data set, and now this new data, our reference profile in this case, let's say this was our production data, and we can see, whoa, it has a little bit more of a distribution that we didn't have in our training data set. Maybe we want to take this new data and then put it in our training data set to account for this kind of new distribution that we're seeing. We could drill down one more time on petal length and see this looks even a little bit more overlapping. They don't go out on both sides quite as far like the other one did. And again, though, you can get those raw values in a dictionary, so you can actually do something programmatically with those values instead of just looking at the visualization if you want to. All right, so one more thing. Let's look at data validation with constraints in ylogs. So kind of like we had mentioned, we already saw when we were looking at our input data that we had some stuff that looked kind of weird, like it was zeros. I think also there might be some negative numbers in there. And then we had values that were really high. So we can set up kind of a unit test for our data and say, if it doesn't meet these criteria, do something about it. So for example, if we had a negative number, maybe we know we should never have a negative number for our pedal measurements. We can set that as a unit test and then not pass that data to our model or trigger an alert directly in our environment. So let's go ahead and import some constraint helpers from ylogs. And then we have this function. I'm going to run this and then I'll talk about what's going on here. So I'm going to create this function called validate features, and it's going to take a profile view in. So we're going to pass it one of those profile views that we created earlier. We're going to initialize our constraint builder. And then each of these blocks is basically a test for our data. They're all doing something very similar here, just looking at different features. So we're saying add constraint. It's a metric constraint. This is the name of it. This can be any string. I kind of like to have this string as what my test is doing. So I'm saying, it's looking for pedal length is greater than 0 and less than 15 centimeters. Maybe I should even put centimeters in there. And then here, we're saying we want to look at a distribution metric, which if we'll see it again in a second, but if you look at that ylogs profile, you'll see it says distribution. The column name is pedal length centimeter here, which is the feature we're going to be measuring. And then this is our actual values that we're going to pass in. We're saying the distribution of min should be greater than 0, and the distribution max should be greater than 15. And we're just doing that for all of those feature names. But you could write different tests, like making sure it's a fraction or an integer and not a string, or making sure it is a string, depending on what your model's doing. So all those different values that we saw in that ylogs profile before, you're going to essentially write a little unit test here and catch those potential data quality issues. So if we run this, we're going to pass in that profile 2, and we get this kind of set of tuples back. And we'll see how to make this more readable in a second. But if it's a 0, if it's here, if it's a 1, that means it's passed. If a 1 was here and a 0 here, that would mean it failed. So let's look at an easier way to read this, especially if you had a whole bunch of features. So in our case, we only have 4 features, but you might have 100 or something like that again. And we can actually generate this really nice looking report, and it tells us that all of them passed here. You can even filter here. You can actually search here. And this is a really useful kind of cool visualization to see, like, all right, out of all my features and tests, which ones are passing and failing. And if you want to do something more programmatically with it, you can call this .validate on it. And this will just say true or false. And it'll say true if everything passes, like it did above. And it'll say false if just any of them fail. So now you can actually use this kind of in your data pipeline, saying, is the data within the constraints that I wrote? Yes, perfect. Go make a prediction with that model. No, then do something else, like trigger an alert, or maybe don't make the prediction with the model, or do some sort of flag with it. So let's look at another profile 4 here. Look at the visualizer. And we can see it failed on one of these. It failed on this pedal width. And we can look at the profile here in a second to see why it failed. Was it a 0 or less than 0, or was it higher than 15? And again, we ran that just validate, so we got false. Look at the whole profile again. And sorry, which one was it? Pedal width failed. So now we can investigate our column here, pedal width. And we can go look at the max and min distribution. So the max was 2.5, so under 15. So it didn't fail there. And if we look at the min, it was actually a 0. And we were expecting it to be greater than 0 for a measurement. So we kind of failed it there. And that is all the features I had planned to show you today in ylabs and ylogs, but there's obviously way more to learn. So if you want to learn more about the metrics for constraints, it's in the notebook, but also share it in the chat. So there's a lot more that you can do to easily set up validation on your data. And also, these links, again, are in the notebook if you open them up. But if you want to request a certificate for the workshop, you can do so here. I love this cute little dog that shows up when it says you're leaving Colab. Check out our upcoming events, etc. And then also I'll share the code one more time if you want to get the enterprise plan promo code. And I'll also hang out for a little bit if anyone has any questions or if people have feedback. What'd you think? Was this interesting? Are these things you're going to implement into a project now, whether that's a personal project or something for work? Has anyone had an experience where they think, like having this totally would have helped? Like I know that someone mentioned the schema issue, right? So if you have some sort of data quality test, making sure that, for example, maybe it's even making sure that it's a type of string versus a number or something like that. You can set up a constraint just like we did, but making sure that the data type is what you're expecting. Or you might want to look at cardinality, and you're always expecting it to be, I don't know, a certain number or a certain number of counts. Like if you always are reading things in batches and you want to make sure that there's always 150 in this case or within a range of that, right? And if it's below, like if it's only 50 for the day, that's a problem. Like that's some sort of throughput issue. You can set up a constraint for that as well. And if there are not any questions yet, or if you have them later, like I mentioned, you should join the Slack channel. I'll share that link one more time as well. And make sure you ask them there later if it comes up, or you can also connect with me on LinkedIn. I'll grab my LinkedIn real quick too. Feel free to connect with me on LinkedIn and ping me any questions there as well, if that works better for you. Otherwise, again, I'll hang around for a little bit more if there's any questions you have right now. If not, I will end the stream soon and hopefully hear from some of you later, though. Did people at least have fun? Someone said thank you. It was great. Awesome. Thank you. Thank you for attending, and thank you for participating in the chat. It always makes it way more fun for me having someone talk a little bit. So thank you so much. All right, I'm gonna go ahead and wrap up the stream then. Thank you everyone for coming. And again, if you do have any questions later, connect in the Slack channel or with me on LinkedIn. And I'd love to hear what you're building and how monitoring can help build more, help you build a more robust and responsible AI application. Rahul said, thank you. Thank you for attending, Rahul. I know you're a regular. It's always great to see you. All right, I'm going to go ahead and actually wrap this up. So thank you again, everyone. And I'll hopefully talk to some of you later.